Hello, ladies and gentlemen. Mr. Hescox here, starting Chapter 1 of our Life Science. In case you haven't noticed, Chapter 1 is all about cells and what are cells, what are the parts of cells, things like that. You should have your vocabulary done. One of your vocabulary words is what is an organelle, which we will talk about in the second section. An organelle is a tiny structure within a cell that does a particular job. This section will break into a couple days. Your homework tonight is read pages 9 to 15 in the text. Make sure that you are checking out the videos, especially if you're at home or when you're in study halls, guys, or when we're in lessons in class, I'll actually play the videos for you. What do you think of when you hear the word cells? Do you think of drawings from science class? What do you think of? I've had all kinds of answers over the years. I want you to think of a definition of a cell without looking it up. You know, we all memorize definitions, but do we know what they mean? You know, a lot of people say tiny little structure within an organism. Every once in a while I get, well, that's where you have in jails. You go to a jail cell. But a cell is the smallest unit of structure and function in living things. Structure meaning things are built out of cells. Function means that cells do what living things need to do. This first little bit is kind of review. The cell is the basic unit of all living things. So we're on the characteristics of living things, which is kind of a review from the beginning principles. The first one, organization. It is organized in a way that organization is a way that organisms can meet its needs. So by cells, by groups of cells, by organs, things like that, that's organization starting with the cellular level. Characteristic of living things number 2, the ability to grow and develop. Living things change over the course of a lifetime. You get bigger, you get stronger. You know, when you get older, you get weaker, and you actually start to shrink after you get so old. Living things have the ability to respond to stimuli. When you respond to stimulus, you are running away from a bear. You are looking at an apple pie and you start to salivate. That's stimulus and response. And then living things have the ability to reproduce. You've got to be able to make new organisms like you. The needs of life. Energy. Energy is needed to do all life activities. Most of the energy on Earth comes from the sun. Some of the energy on Earth comes from the sulfur in the deep ocean trenches, but not very much. The materials that we need, these are your water, air, and nutrients. And then finally, we need living space, and in your living space, you will find all of the needs of life. So you've got to find everything in your needs of life. If it's sunlight, if it's water, if it's nutrients, if it's food, that all has to be found within your living space. You want to watch the biology song again? There it is. So let's start breaking down the characteristics of life. So all living things are made of cells. There are 2 types of cellular organisms, a unicellular organism and a multicellular organism. In the word unicellular, you have the prefix uni. If you look, UNI means one, and then cellular of or relating to cells. With multicellular means many cells. So bacteria are unicellular, cats and dogs are multicellular. The microscope led to the discovery of cells. Now, there were lots of gentlemen who claimed to invent the microscope. Zacharias Jensen is often credited, but it's not definite because so many people were actually building them. Why do people build microscopes? What are they used for? Well, they allow us to see things that are too small to be seen. When it comes to the cell or the history of the cell, the first person to give the cell its name, a cell, was a gentleman by the name of Robert Hooke. He was English. It looks like hooky, but it's pronounced hook. And he was observing cork cells, which is actually out of the bark of a tree. And he said that each cell looked like tiny rooms. If we take a look at this picture and zoom in a little bit, this is a picture of what his looked like. These little squares are the tiny rooms that Robert Hooke was describing. Now, Hooke was not looking at living cells. Living cells are not found in bark because most of the layers of bark are actually dead. This gentleman is Anton von Leeuwenhoek. Leeuwenhoek was given credit as the first person to see living cells. Now, he was a Dutch lens maker and merchant, and he ground all kinds of them. He made some weird looking microscopes. His looked like paddles almost. But he was the first person to look at pond water. He looked at the gunk on your teeth. He looked at insect parts. And when he looked at the pond water, he called it animalcules, which meant tiny animals. He thought he was looking at tiny animals. He was actually looking at tiny protists. Hooke, Leeuwenhoek. There was a gentleman by the name of Schleiden and Schwann, were two more scientists who were very, very important. They came up with something called the cell theory. A theory is used to explain things in nature that has had many things to support it. Many experiments support this conclusion. The first part of the cell theory is every living thing is made up of one or more cells. So everything is made of cells. Cells carry out the functions needed for life. That means cells do the things that living things need to do. And finally, cells come only from other living cells. Now, that last one's kind of weird, and it sounds kind of funny, because there was this belief hundreds of years ago in something called spontaneous generation. Spontaneous generation, or the fancy word meaning abiogenesis, spontaneous literally means instantly. And then generation is to create. To spontaneously, to instantly create life. The biggest example that I can think of is that they thought that flies came from dead meat. I know how they can maybe jump to that. I've seen deer hit along the highway, and you've probably seen the flies on the dead animals on the road. Well, people actually thought that the dead animal caused the flies to happen. So let's talk about some other ones. So the meat causes flies. They used to think that bales of hay in the barn caused mice to happen because many times you'd lift up the hay and what would run out? Mice. There was the belief that frogs came from logs in a pond. Because when you walk by the pond, if there was a log, oftentimes there was a frog. There was the belief that underneath rocks, the rock caused all of the insects and worms to be there, not that they just lived under the rock, that the rock spontaneously created them. So as you can see, it's kind of a silly idea today. I've seen cats give kittens. I've seen mom deer have fawns. Humans have babies. We know that it should have never happened to that, but it did. Well, Francisco Redi knew that there's no way this could possibly be. So he set up a very, very famous experiment using 3 sets of jars, and I'll show it to you here shortly. One jar was open. One jar had cheesecloth on it. Now, cheesecloth is a material that they would use to strain the solid parts from milk when they were creating cheese, and it would keep the solid part in it and let the liquid part go away. And in the third setup, he put a lid on it. and it looked something like this. Now this is a student's from a couple years ago. So here's my open jars. After a couple weeks, the meat's decaying. There were flies and maggots on the meat. My cheesecloth jars, the meat still decayed, but he noticed that there were maggots crawling on the meat and flies. And then finally, in the jars with lids, nothing happened. If spontaneous generation were true, there should have been flies in every one. There should have been flies in every jar, even the ones with the lid, if meat caused them. One more scientist who's very important in this, his name is Louis Pasteur. Louis Pasteur further disproved spontaneous generation with his famous pasteurization experiment. Probably you've all had pasteurized milk in your life. Pasteurized happens a lot with food, where we heat up the food to kill any bacteria that might make us sick. It makes your milk last much, much longer in the store, keeps it from spoiling. So I will show you this in a second, but Reddy took 2 flasks and boiled them. Now when you boil the broth in the flask, this was not broth like chicken broth, beef broth. This had nothing to do with making soup. The broth that he made was what we call nutrient broth that they used for growing bacteria. And he actually invented this goose-necked flask. Now, I'm not a very good drawer, but you'll see it looks like this. The gooseneck prevented air from getting into the flask. So if air can't get into the broth, nothing happened. And what he found was the broth did nothing. Now, later, they broke the neck of the gooseneck flask. Now, this is another student's picture that I liked. And when air gets in, dust particles got into the broth. Bacteria can ride on the dust particles in the air. When that dust particle got into that nutrient broth, it was like bacteria happy, happy fun land until the broth turned dark and cloudy with bacteria. If spontaneous generation were true, all of these should have turned cloudy, because they should have, if broth actually made bacteria, it should have all been the same. Your homework assignment is going to be drawing one of these. So you can draw it, take a picture of it on your iPad, and it'll be in the assignment. We're going to stop here for today. If you have any questions, you need to see me, you can send me a message via Remind. You can send me a message through Classroom. And until next time, ladies and gentlemen, have a great day and be safe.